Hello everyone, so today we're going to follow through with the last session. We've done modeling quadratics, we've covered a couple of examples, and we have two more today. A fertilizer company uses a model to determine how the amount of fertilizer used, F kilograms per hectare, affects the grain yield, G, measured in tons per hectare. So basically what I said so far, that we've got an amount of fertilizer that is referred to as F, and the grain yield referred to as G in their measured units. And it's modeled by this beautiful quadratic equation over here. I can see that's his quadratic equation because if we were to look at it, it's going to be like AF squared plus BF plus C, like the usual quadratic equation where G is more like, I would say, Y, and F is what we normally say as X. So part A, according to the model, how much grain would each hectare yield without any fertilizer? So one thing, what I'm looking for how much hectare grain would each hectare yield. So I'm looking for the grain yield. So I'm looking for G, and what do I have? F. F is equal to 0 because we're looking for that kind of amount when there's no fertilizer used. So when fertilizer is not used, when F is 0, G will become 6 plus 0.03 times 0 minus 0.0006 times 0 squared, which is simply 6. Thus, each hectare yield 6 pounds without any fertilizer. Easy and simple. So moving on to part B, one farmer currently uses 20 kilograms, okay, and of fertilizer per hectare. So we know that F is equal to 20 kilogram per hectare. So I'm writing every piece of information I have because it will be useful later. So now I'm asking how much more fertilizer would he need to use to increase his grain yield by 1 ton per hectare. So that means at this moment of time when we use 20 kilogram per hectare, he has a specific grain yield. However, we would like to increase this grain yield by 1. So instead of, for example, if my grain yield is like, I don't know, maybe like 5 tons, I would like it to be 6 tons instead. But how much fertilizer would make that kind of thing work for me? So let's first find out. We don't know the grain yield, the current grain yield, but we know the fertilizer amount is used. And given this quadratic equation, we can figure out accordingly. So G is 6 plus 0.03 times 20 minus 0.00006 times 20 squared. And thus we found that, simply putting this in a calculator, we can find that the current grain yield, I think, is something like 6.576. Let me check. Yes, it's 6.57. So I want to increase it by 1, so I would like it to go from 6.576 to 7.576. We just increased it by 1. So given this value over here, how much fertilizer is going to be used? Because basically what we're looking for is how much more fertilizer would he need to do that. So given G equals 7.576, solve for F, So given one variable, we can find the other one. So 7.576 equals 6 plus 0.03f minus 0.00006 f squared. So this is what we have in front of us, the quadratic equation. We solve it using the normal means. So moving these variables to the left hand side so we can get an equation that's equal to 0 before we use the quadratic formula. So 0.006 f squared minus 0.03 f. So they change sign because we moved them to the left. And this one becomes minus 6. So directly will become plus 1.576. I don't want to, write it over 2 steps. So now we can use the quadratic formula. The quadratic formula states that is minus b. So in this case, b is minus 0.003, and it becomes 0.003 plus or minus b squared minus 4 AC. So 0.00006 times 1576 over 2a. So 2 times 0.006. And let's compute the values of f. So we either get f equal to 440.35. So let's keep it to like one decimal place. Or f is equal to, I think, 59.64. Let's just keep it at 59.6. So realistically, if I'm a farmer, yeah, if both of these values will give us a certain grain yield, I would realistically it would cost me more money to use more fertilizer, so I would go with this value. So this one is unrealistic to use it, and in fact this will reduce the grain yield later because the curve looks like this. But anyways, only for the sake of common sense, we'll use this value. So we'll consider this value, but the question is not asking is asking by how much would we increase, because he originally used 20 kilograms. So what we'll do is this new value, we'll subtract from it 20 kilograms. So 59.6 minus 20 is 39.6. That means he has to use 9.6 kilogram per more fertilizer per hectare, if that makes sense. So we should increase the fertilizer amount by this current value over here. So I hope it made sense, and we shall move to another question. So we have a football stadium has 25,000 seats. The football club, I know from past experience that they will sell only 10,000 tickets if each ticket costs £30. They also expect to sell 1,000 more tickets every time the price goes down by £1. So, so in this context of this problem, we're given question A, the number of tickets sold T. So tickets are referred to by T, and the price of the tickets they refer to as a little p. Can be modeled by the linear equation m minus 1,000 p, where p is the price of each ticket, mn is a constant, and we have to find the value of m. So there's an important information here to note, that given this linear equation, this piece of information over here must be satisfied this information. So I think a simple substitution. So for t, we'll find m for us. So for t equal 10,000 and p equal £30, we will find m. So 10,000 equal m minus 1,000 times 30. So m is equal to 10,000 plus 30 times 1,000 is 30,000. If I move it to the other side, it will be plus. So m is simply 40,000. Okay, is that clear? I think it's clear enough. So it's just a simple substitution, and we ended up finding the value of m, which we'll be using for the rest of the question because we still have one more part. So the total revenue R can be calculated by multiplying the number of tickets sold by the price of each ticket, and this can be written as R equal P M minus 1000 P. So in these problems, sometimes like there's a lot of wording, but it's as simple as like you have two variables, and you just use the piece of information that you have to solve it. So in this question, it says rearrange R into the form A minus B, P minus C, where A, B, and C are constant to be found. So M that we already found, so our current equation is R equal P 40,000 minus 1,000. So this is the equation that we are dealing with right now. So basically, this form is the completed square form. We all know how to complete the square. I've got a video on that if you want to check it out. So we'll basically expand this first. So we have 40,000 e minus 1,000 e squared. So I'm just gonna move the order because for me, I'm more comfortable dealing with it that way. So minus 1,000 e squared plus 40,000. So this is all good. So I know that in order to deal with this one, I have to isolate. I need to get something like p squared plus something plus p, So to do that, I need to factorize by minus 1,000. So let me factorize by minus 1,000 here. So minus 1,000 p squared. 40,000 over minus 1,000, that's minus 40, I believe. And minus 40p. So now we factorized. Now we can actually use the formula that we have. So the formula says if you have x squared plus bx and you want to complete the square, you can do x plus b over 2 squared minus b over 2 squared. So in this case, my b over 2 squared is minus 40 over 2. So my b is minus 40. So it becomes minus 1,000 p minus 40 over 2 squared minus 40 over 2 squared. Easy and simple. Minus 1,000. So 40 over 2 is 20. So p minus 20 squared minus, so 20 squared minus 20 squared. We can simplify later. So minus 1,000, so I'm going to expand. So I'm going to have minus 1,000 p minus 20 squared minus 1,000 times this. Okay, so minus 1,000 times minus, so it becomes plus, and minus 20 squared, if we were to calculate it, will become 400. So simplifying, p minus 20 squared plus 400,000. So we haven't done much here. We're just like literally simplification. The crucial step is this one, is going from here to here, like the right way. Other than that, that's just like simple simplification. So I'm gonna rearrange it in a way that it looks something like this. So I'm just gonna, swap the orders. So 400,000 stays here. I'll put it here, and this one becomes here. So I can comfortably select my A and B and C. So A, in this case, is 400,000. B, as you can see, is 1,000. There's a minus here, so it's not minus 1,000. And C is 20. So part C. Part C, using your answer to part B or otherwise, work out how much the football club should charge for each ticket if they want to make the maximum amount of money. Um, in our previous sessions, we've known that in a quadratic equation, every quadratic equation, it should have like a turning point, and that turning point, it's either a maximum or a minimum. And how do we know? Just as a reminder for you all, by the coefficient that is related to the highest power, p squared. Like whether you have x squared, whatever, you just look at the coefficient. If it's negative, it's, let's say a is the coefficient. If it's negative, it will look like this, like it's sad. And if it's positive, it will look like a smile. So in our case, it's negative. So it looks like this, something like this, right? And eventually, this is a maximum, okay? But if we have something like this, we will have a minimum, okay? So I'm just trying to explain to you the reasoning behind this. So completing the square of the quadratic equation, writing it in such a form, it makes it easier for you to find, take the variable out of like, what is the maximum? Like it, you take it just literally when you complete, you can just like literally look at it and you know what is the maximum, what are their coordinates. So looking at this, because it's written in such a way, I look at the completed square form, okay? So let me give you like a general kind of form. So if we were to look generally at this, then like C for C equal and CA, that's gonna be my maximum. In this case, C is 20 and A is 400,000. What does, because speaking in coordinate form, this is P and this is R. This is the revenue and this is the price of the ticket. Okay? And then the question says work out how much to charge for each ticket. So indeed, the price to make the maximum amount of money, which is the revenue, to make the maximum amount of money that's been made is 400,000, and the tickets that's linked to actually getting that kind of revenue is £20. So in this case, they only ask for the price of the tickets, so they should charge £20 per ticket. And this trick, you literally use it for every, like whenever they ask for maximum or minimum, this is how you do it. You just complete the square and then you look, like it should always be like minus something. And that something is gonna be like what goes in here, okay, for x. And the value that's outside of the bracket, that's what it goes in here. So I hope that makes sense. This is the price, this is the revenue. And I think this should mark the end of this session, and I shall see you in the next one. Bye.